Suppose you're given these two functions, f of x and g of x. The composition of these functions means combining them in a manner whereby the output for one function becomes the input for the next function. So basically, if you look at what I have here, so this, what is inside this bracket here, which basically is f of x, is the input for g. Now this is the composition of g and f, whereby f is applied first before g. So this is just a notation for the composition of these two functions. So we are combining these two functions in this order. So like I've just said, this means that um, this will be the input for g. Yeah. So it means that the output for f of x, which is given by f of x as highlighted here, becomes the input for g. This can be represented in a diagram as what's shown here. So of course you start with x and then you apply f first of all to end up with the output for f, which is given by that. And then you apply g. So g takes the results of f. Yeah. So basically here, g takes the results of f. Okay. And if the g takes the results of f, what you'll end up with will be g of f of x will be, now remember here, what g does, it squares the input and adds 1. So if the input is 3 of x, it will square 3 of x and add 1. Now 3x squared will be 9x squared plus 1. So that will be the output for g, and that's what you have here. So this is a composite function. And this composite function is the output from a composition such that f of x is applied first, uh, followed by g. So basically you have f being applied first, followed by g. I mean, this is just the details of the process behind composition of functions. But just remember what I've said. If you have g of f of x, that means that you input what is here. I mean, the way it's written here, um, the highlighted portion is what is plugged into G, and the highlighted portion here is the results of F. So the results of F here is 3 of X, and then that is what G takes. Yeah, that will be the input for G, and that's represented here. So this is basically that, which is, as you can see here, is represented by that. And then, of course, you just simplify and then you end up with your results. All right, so let's look at how we can. So basically, this is the notation for a composite function where f is applied first, followed by g. And it's just written as g of f of x. So let's look at some examples and see how we can manipulate different questions in different ways depending on what has been asked. So for number one, you have f of x and g of x. And in part A, we are required to basically find g of f of x. So g, this is another way that this is written. So you'll see most of these notations in your textbook. It's just the same as what I'm writing here. So this is same as g of f of x. Now, as you can see here, g is taking the results of f. Now, the results of f happen to be that. So basically, we are going to plug those results in G in place of X, because basically this is what's being taken by G. And what G does is multiplies by 2 and then subtracts 2. So this will be equal to 2 multiplied by 3x plus 1 minus 2, which will be, we are required to simplify our answers. So this will be 6x plus 2 minus 2, which will just be equal to 6x. So in short, basically, um, if you have this composition here, just take the results of f and plug them in G in place of x. Yeah, so you take the results of f, which is basically here, and then you plug them in G in place of x. And that's basically what has happened here. We can apply the same approach for part B. For part B, we are required to find f of g of x. So I'll plug g, the results of g, which is 2x minus 2, in f in place of x. So that will be 3 into 2x minus 2 plus 1. So this one comes here in place of x. And the result will be 6x minus 6 plus 1, which will be 6x minus 5. All right, so one thing that you may notice here is that here f is applied first followed by g, and here g is applied first followed by f. And we can notice that if you reverse the order, then you don't end up with the same result. So we have g of f of x is not equal to f of g of x. So if you reverse the order, um, the result is rarely the same. Sometimes the result may be the same, but it's not always the same. So we can say that when we reverse the order, when we reverse the order, uh, the result is rarely the same. Okay, let's move on to number 2. Um, in the following cases, find f of g of x. So that means we plug g in f in place of x. So f of g of x will be equal to, we plug g in f in place of x. So this basically here gets plugged here in place of x. So what we end up with is 3x plus 4 squared, which will be equal to 3x plus 4 multiplied by 3x plus 4, and we can FOIL that. So we end up with 9x squared plus 12x plus 12x plus 16, which will be 9x squared plus 24x plus 16. Okay, for part B, we are plugging G into F. So we take that and plug that in F in place of X. So basically we have F of G of X will be equal to 2 into 3x minus 4 plus 3. and that will be equal to 6x minus 8 plus 3, which will be 6x minus 5. Number 3, we are required to find the values of these compositions at x is equals to 4. Now, there's a trick that we can use here. So basically, we are required to find the value of the composition of f and g such that g is applied first at x equals to 4. So when I highlight this portion, the inside portion, what's being plugged into f, we can see that the inside portion here is the value of g, which is this function, at x equals to 4. That is what you're plugging into f. So we can say, but the value of g at x equals to 4 will be equal to 4. Of course, you just plug here x in place of, 4 in place of x in this function. So that will be 4 over 2 plus 3, which will be equal to 5. And then this function here, or this notation here, becomes f of, we know that the value of g at x equals to 4 is 5, so just replace 5 with the highlighted portion. So ideally, what we will be finding here is the value of f at x is equals to 5, and that will be the composition of f and g at 4. So anyway, if you work this out, remember this is a simplified version of that. So this will be equal to 5 squared minus 5, because this is f, you're plugging 5 in place of x. And this will be equal to 25 minus 5, which will be equal to 20. So you can apply the same approach here. Just rewrite this in this form. So g of f of 4. And we start with the inside portion. So, but f of 4 is given by, so the value of this function at x is equals to 4, which is written as f4, which is inside here, will be equal to, we plug 4 in place of x here, so you'll have 4 squared minus 4, which is 16 minus 4, and that will be equal to 12. So it means that basically what we'll be finding is the value of g at x, which is now the new input here, x is equals to 12. Now if you plug 12 in place of x in g, you'll have 12 over 2 plus 3, which is 6 plus 3, and that gives you 9. So that's basically how you solve these composite functions for specific values.